In the previous video in this series we stripped the unit down into its major sub-assemblies. The main board was in fairly good condition, no idea if it works yet, and then I turned my attention to the power supply. So I've cleaned this up and there are a few issues with it. The first is, as we can see, these diodes have been getting fairly hot, but also the connector itself is getting hot. Now I believe that's just down to poor contacts, and in fact this end of the connector was getting so hot, I don't know if you've able to see this, but it's actually started to desolder itself. It's lifted itself out of the board. So there's about a millimeter gap between the connector and the board where these connections have become molten and the connector itself has started working its way out of the board. I believe that's just down to poor contacts, so I'll try cleaning these up. They were fairly badly corroded. The entire machine, I think, has got a lot of corrosion because it's been stored somewhere damp by the look of it, probably somebody's garage, and there's corrosion on various parts, and poor contacts with current flowing through them will of course generate heat. So I think that's what's happened here. So I'll suck the solder off these connections, press the connector back in, resolder it, and try and clean up the pins. If I can't clean up the pins, I'll probably just swap the connector, but the actual plating seems to be intact, so it may even be the plug that's at fault. We'll check that as well. Might need to put some new crimps on the end of the wires, but I'll look at that when I get round to the chassis. The rest of the components actually measure okay. These two capacitors measure fine. At the end of the previous video I put the two main capacitors on test. They've been sitting here now like this for about 14 hours and they seem to be fine. No sign of any leakage. They're running at close to their maximum voltage, and I don't think there's any issue with those two. The one that I took out and showed I will have to replace. I do have a replacement for that. The rest of the board seems fine, but we do need to look at the actual regulators, the active components. So there's two on the heatsink. Now these are in sockets, and so I've taken the screws out of this one, and then we can just unplug it from the socket. Now sockets tend not to work that well on the modern versions of these components. The original versions of these would have had gold-plated legs, pins, and this type of socket works well with those. But firstly, you can see this is quite badly bent. There's no heatsink compound on this whatsoever, and the pins themselves have got some fairly mild but not insignificant corrosion on them, so I will need to test this and clean up the pins on both of them. Then I can put them back in, replace the screws, and then as I said, I can start checking these crimp connectors to make sure that they're okay. But if these don't plug in and make good contact, they can overheat just because of the high resistance contact, for the same reason that the connector got hot. So I will check those, clean them up, and hopefully they will be okay. So the next thing I'm going to do with this is refit the capacitors, replace the capacitor that's failed, clean up the pins on the power devices, and then we can plug this together on the bench and see if it actually works. I don't have any technical information for this, but what I'm expecting to find in terms of power rails, bear in mind it's a dumb terminal, is a 5 volt rail for the main logic, plus or minus 12 volt for the RS232, and maybe something like a DC rail for the monitor. The monitor may be run directly off the transformer from AC. We'll have to look at that when we start going through the machine. But we can test this supply before we connect it to anything else to make sure it's not, for example, feeding 12 volts straight through to the 5 volt rail. So I've reassembled the power supply. I've replaced the failed capacitor. I've used a multimeter to check the other devices, the diodes. I've tested the capacitors. All now test good. I removed the two TO3 regulators that were in sockets, cleaned the pins, put some heatsink compound on the one that was missing it. I think that device may have been replaced at some point in the past, and as you can see, I've reassembled it. It had a permanently attached mains lead, but that was fairly badly corroded, and as I was going to change it anyway, I took the opportunity to replace the fixed grommet on the back plate with an IEC socket. I'm not trying to restore this machine, just trying to get it working, so I decided to put an IEC socket. It will make it far more convenient to use this machine in the future if I can get it working. I've had a look and noted that a couple of the pins on this connector, this is the connector that comes from the transformer, were getting extremely hot, and to the extent that they had kind of desoldered themselves and started pulling out of the board. And I resoldered that, took the solder out, resoldered the pins to the board. Pins themselves look fine, but I started pulling each of the crimp connections out, and what I found was that the reason they're overheating is they're making poor contact. You probably can't see this, but part of the connector, or the crimp, is actually missing. Should have another fold back on this to give it plenty of spring force, so it should look a bit like this one. Again, you probably can't see it, but the others didn't have the fold back, and this is too compressed as well, so there's no real spring or life left in this. So I took all the crimps out, re-crimped them. These have now got fresh new crimps in, and it's now quite a nice tight fit. When I pushed it on originally, it was almost no resistance at all, so I think that's why the pins were overheating. I think it was just too low contact pressure, and the current flowing through was just overheating the pins. So fix that. Now luckily the main chassis, in particular the CRT control board, has voltage indications as to what we should expect from this connector. So from the top, the red connection, I believe, should be 13.8 volts. Then we've got ground. There's a blank in this one as well. Then we've got ground. The white lead, I think, should be plus 12 volts, and the brown plus 75 volts. There's no indication on the main board, but I believe by buzzing out the connections this goes to, I think the top connection on here should be minus 12 volts, and then the black lead, again there's a blank in this, the black lead is 0 volts again. The green should be plus 5 volts, that's our main plus 5 volt feed to the main board, and then the white is plus 12 volts. That's kind of what we'd expect on the terminal, 5 volts and plus or minus 12 volts, and then whatever voltage the monitor requires. Haven't powered this up yet. I've buzzed it all out and it seems to check fine. The main power switch was a bit flaky, it didn't always make good contact, so I've cleaned that out with some contact cleaner, and that now seems fine. Check the main fuse, that seems fine, and so I think we're good to go and give this a test. So all I'm going to do is power this up. I've got it connected to the bench supply. It's set to around 200 volts. We'll just limit that until I've made sure nothing's going to explode. One thing that's come up that I think I'll just clarify here is when I make these videos, I video what I'm doing as I progress. They're not contrived, they're not staged, and they're not scripted, as you probably gathered by my ramblings sometimes. But what that does mean is that when I stop videoing for a particular video, I can't touch the machine again until I turn the camera back on to start videoing for the next video in that series. So comments are always useful, but just bear in mind that something I may intend to do I haven't done already, simply because I haven't got to that stage of the repair. Now, a good example of this was in the previous video I said I thought this machine was a Televideo model 950. I'm not absolutely convinced yet that's the case. I still think it might be a 950, but it might be a variant of the 950. And the reason for that is I also said I don't have any technical documentation for this, which is not strictly speaking true. I do have the user and service manual for the 950, but it doesn't match the machine I have. The power supply is the same as shown in the manual, and the CRT display board is the same. The general layout and appearance, everything else looks identical. but the main board layout is completely different on the machine that I have. Different processor, different board, so I think it's either a completely different version of the machine or it's just a variant of the machine. Now, one thing I would normally do at this point, because the board has ROMs in it, and I had a suggestion, and the reason I'm sort of saying all this, had a suggestion on the in the comments of the previous video saying that I could look into the ROMs and see if there's anything in there to indicate what the machine might be. Yes, that's what I would normally do, but I haven't done it yet because I haven't got to that stage in videoing, and I don't want to work on that without the video being kept up to date. So I haven't done that yet. That will be the next step after we've tested the supply. Once we've got the supply working, we can then turn our attention to the main board and start trying to figure out what the machine is. So comments are much appreciated, but just bear in mind certain things I may plan to do. The reason I may not have done them already is because we haven't got to that stage in the process yet. And I don't jump ahead and then retrospectively try and tell you what we might be finding. I want you to see these repairs as they happen. Okay, so we'll get the multimeter, and the next thing I'm going to do, of course, is power this up. And step one is to make sure nothing bad is going to happen. Now, there is a current meter on the bench supply. You can't see it, but it will probably be fairly evident if something goes wrong. So I'm going to power this up now. Okay, it's drawn about 10 milliamps, which is fine. Nothing bad is happening yet. Neither fuse has popped. So next step is we'll try measuring some voltages and see what we get. So starting with this connector. So I'm on ground, so referencing everything to ground. The first pin, these are fairly unregulated, but should be around 13.8 volts. 14.2, there's no load in it either, so it will be slightly high. So that's fine. This one should be plus 12 volts. Again, no load on it, so that is fine. And this one should be 75 volts, and that's fine. Okay, and on the other connector, again, I believe this is the ground pin, and the first voltage should be minus 12, which is correct. The next one should be plus 5, so main 5 volt, so that's important, that's fairly close to 5 volts, that's fine. And the last one should be plus 12 volts. Again, no load on it, and that looks fine. So they all look like they're doing what they're supposed to. So what I'm going to do now is leave this running for a couple of hours, come back, and hopefully nothing bad will have happened and it will still be working fine. That being the case, we can turn our attention to the main chassis and start trying to figure out if it works and also what it actually is. It's about 3 hours later. The supply has been powered continuously. There's no load on it, of course, so things might change once we load it up. I've just rechecked the voltages and they're still all fine, so nothing bad has happened. All the capacitors are still intact, and the next step is to get it out of the way. We'll get the main chassis back onto the bench and we can start working on that again. Things are now starting to get a bit interesting. I originally thought this was a Model 950. I have worked on a Model 950 before, but when I opened it up, as I said earlier, this didn't look familiar. It looked completely different to what I remember having seen in the Model 950. The case was identical, but what was inside didn't seem to match. But you do sometimes get that. You get different variations as the machine develops. But what was in here didn't seem to be making a lot of sense. Now, as I said, what I was going to do was take the ROMs out, try and read those. So I took them out and all three read fine. And as soon as I started to browse through them, then the penny dropped and I realised what this actually is. If I show you the keyboard, it's in terrible state, but at the top right hand corner you can see it says TS802. Now that didn't come as a surprise to me, because the 950 I worked on previously, which was definitely a 950, the keyboard on that one also said TS802, so I'm not sure if they're standardised keyboards or if somebody had swapped it or changed the case. So that didn't surprise me at all. I know it's not a TS802 because the TS802 it's a computer system with a terminal in it, and it actually does use this board apparently. But it's a wider machine, it's got built-in disk drives. So I knew it wasn't one of those, and I have worked on quite a few of those in the past, which I think is where I've seen this board before. And then looking at the board more carefully, I hadn't really looked at this that carefully, but looking at it more carefully, I realised that we had two processors. We've got a 6502 and a Z80. Now the TS802 does have a smaller brother, and it's the TS800A, not to be confused with the TS800, which is totally different. The TS800A, as I say, it's a smaller brother to the TS802. The only real difference is it doesn't have incorporated disk drives in the main case of the machine. So it's a smaller case, and in fact it uses the 950 enclosure. It's identical from the outside. The only way you can really tell is the extra sockets it has on the back, and in theory a model number printed on it somewhere, but this doesn't have that. I have checked again and there is no model number printed on this anywhere. But in the ROMs, browsing through, it became evident that the ROM for the Z80 contained text to indicate that this not only was looking to power and control floppy drives, but also that it was a TS800A. So what you have here, it's a bit of an unusual machine. On the left hand side of the board, so it's divided down the middle about here, the left hand side is the 950 terminal. So it's identical circuitry, it's laid out differently, but identical circuitry to the 950 terminal. And then on the right hand side here, as you're looking at it, there's a Z80 computer system. So it's combined, it's a terminal and a incorporated Z80 computer system. So quite interesting, a bit of an unusual arrangement, but it makes it an interesting machine to work on. I've never worked on a TS800A before. Worked on one of these boards before, but again that was a long time ago, and it kind of looked familiar when I saw it, but I couldn't place where I'd seen it before. Now if this was in a model with the disk drives, either floppy disk or hard disk, there's a daughter board that plugs into this connector. I don't have that. It's not included in the 800A, but once I'd realised what we were looking at, I changed tacks a little bit as to how I was going to approach this, and you can see I have been working on this a little bit. I did actually video it, but for some reason my camera decided to delete the footage, and I didn't want to repeat it because it kind of looks contrived if you do that. So what I've done is I didn't bother putting this back in the chassis. I hooked it up to the power supply so I could power this up, and I'm still not certain exactly how this arrangement works. I know the two computers talk to each other through one of the SIOs, and the Z80 has some startup self-test, and the reset for the Z80 is controlled from the 6502. But the Z80, basically the board wasn't doing anything at all, it wasn't coming to life when I powered it up. And there are some LEDs down here that indicate the status of the self-test as the self-test is performed. But none of the LEDs were coming on, wasn't doing anything, so I went through the usual course of actions, which is to check the clock going to the Z80. That was fine, 4 MHz clock going there, that was in good order. Good amplitude, nice and clear, but the reset pin was permanently low. It wasn't being released from reset. Now every now and again if I flick the power on and off, it would come out of reset and the LEDs would start to do something, not really what they're supposed to, but they were doing something. And the next thing I did was to put the Fluke 9010A on this. So I took the two SIOs out just so there wasn't any contention with them. Took the Z80 out, tested that separately, and that works fine. Put the Fluke on here, and when I did a bus test I was getting data bit 1 stuck. So I popped out all the DRAMs, you can see them sitting over there in the corner, and once I'd taken them out the bus test passed. put a new set of DRAMs in, bus test still passes. The RAM check from the 9010 fails, but that's not that surprising. So that's as far as I really went with this. I went through a learn cycle and with the 9010, and it failed on various points as it was trying to interrogate the system. Now this apparently has two RAM banks, and the self-test starts by testing the first RAM bank, and I believe, I can't find anything particularly definitive about it. Instead, I have found a technical manual for this now, and I've downloaded that and I've been going through it. Still need to go through it some more yet, but I believe that the self-test are 4 LEDs. I think the first one comes on while it's performing the RAM test of the first memory bank. The next one comes on when it's testing the RAM test of the second RAM bank. The third one comes on when it's testing the DMA controller. It uses a Z80 DMA controller. And then the fourth LED comes on when it's testing the SIO. Now what happens is, in fact I'll show you what happens. I'll turn the power on. You can see the LED comes on solidly for about 1 second, and then it starts flashing. And I believe the flashing is to indicate that that test has failed. So the test apparently is it fills the entire memory bank with a known value. It then goes back, reads it, and it should of course be the same. And the LED seems to be on just long enough for it to fill the bank with the data. So I'll turn the power off and back on again. You can see it does that every time. However, if I fit the 6502 into its socket, it normally goes in here, the Z80 won't come out of reset. It's been held in reset by the 6502. So chances are the 6502 is not running either. So by removing it, it seems to allow the Z80 to come out of reset. But because the Z80's operation is controlled from the 6502, it's quite likely that by just removing the 6502 that the two halves of the system are fighting, and that could be why the RAM test is failing. So it's got quite interesting. I'm going to go further with this and see if I can at least figure out why it's not running. I know the DMA has failed, but that's not why the RAM test is failing. We'll wait until we get to the DMA part of the test before we look into that further. So really the next step for me on this is to attach the logic analyzer to the Z80. We'll look at that in conjunction with the code that's in the ROM and then try and figure out exactly what it's doing. I have looked at the buses with the scope to see if there's any contention between the two halves, and there doesn't seem to be. But as I said, the chances that the Z80 will run with the 6502 removed seems fairly remote. It might do, but that could be what's causing this particular fault. And certainly the fact that it won't come out of reset with the 6502 in place means that something's not working the way it's supposed to. Could be this corruption in the ROMs. They did read okay, but it doesn't necessarily mean that what's in there is correct. They may have started to erase themselves. It does happen over time with ROMs, and I don't have the source code for this, so I don't have any way to compare what should be in there. That will be the next thing I'll be searching for. So it's quite an interesting machine. We'll persist with it a bit further, see if we can get it working, but a very unusual combination. So in the next video we'll attach the logic analyzer, start stepping through the code on the Z80 side, and then if we need to we can also step through the code on the 6502 side and try and figure out exactly what is going on.